Okay, problem 5 from chapter 22 of the Smith's Chemistry textbook asks us to, sketch some structures. And of course, these are all carboxylic acid derivatives, so let's go ahead and do that. So 5-methyl heptanoyl chloride. Remember that this is a derivative of heptanoic acid, okay? So let's sketch out heptanoic acid. So there's 6 carbons in a chain. We want to put a methyl group on carbon 5. Okay. And we want to put, instead of a carboxylic acid, make it an acid chloride. Okay. In molecule B, we've got a derivative of propanoic acid. Propanoic acid has 3 carbons. Okay, propanoic acid. And this is an ester, right? It ends in the 8 terminology. And so what we want to do is hook on an isopropyl group here. So an isopropyl is 3 carbons with the branched point connecting, okay? Here we have an anhydride, okay? And remember, anhydrides are basically 2 carboxylic acids hooked together. So we have acetic acid and formic acid. So acetic acid looks kind of like that with an OH, and formic acid looks like that, okay? So that would be your acetic formic anhydride. In molecule D, we've got this pretty long name, but remember that the italic ends designate what is connected to them, okay? And butanamide is an amide, of course, and it's a derivative of butanoic acid. So we want to sketch 4 carbons out here, right? So here's 4 carbons. That would be your butanoic portion. We need to make this an amide, so we'll sketch in a nitrogen here. And then we want a methyl group, okay? And then we want an isobutyl group. Okay, so an isobutyl group looks like that. There's a total of 4 carbons, and it's connected through that carbon. All right, so moving onwards, let's do E. So we've got pentane and nitrile, okay? Now remember, the nitrile group itself contains a carbon, so you want to include this carbon in your carbon chain. Okay, so we want 5 carbons, so I'm going to sketch in 5 carbons there. And we've got a methyl group on carbon 3, so I'll sketch that in right there. Okay, so that would be your 3-methyl pentane nitrile. In F, we have benzoic acid, so we can kind of always build it by reading the name backwards. So benzoic acid looks like this. And we have an ortho-substituted guy, and we want a cyano group. So a cyano is CN. We can draw it in as a line drawing or just draw CN. Okay. In G, we have sec-butyl 2-methyl hexanoate, okay? So the first part of this name, you can see there's a small space here, okay? The first part of this name is the R group, okay? An ester, remember again, ends in O8, and it's always going to have this kind of feature. This is going to be the first name, so we want to put a sec-butyl there, okay? And the second part of the name is going to be here, which is the 2-methyl hexane, okay? 2-methyl hexanoate. So I'm going to build it backwards, right? So let's draw hexanoic acid. I always count my carbons because I generally make mistakes, as I just did. Okay, so 1, 2, 3, 4, 5, 6. Double check everything. Put a methyl group at carbon 2. Okay, and so that's my 2-methyl-hexane portion. Okay, and then I want to draw my sec-butyl group there. There's the sec-butyl group, okay? All right, so H is N-ethyl hexanamide, okay? So remember, when you have the italic N's, that means your ethyl group is attached to the nitrogen. Of course, this is an amide, and we want 6 carbons, okay? So let's draw hexanoic acid. Okay, so there's 1, 2, 3, 4, 5, 6. Okay, that's good. So here's our hexanamide, okay, with the nitrogen. And we want to draw an ethyl group on the nitrogen. And nitrogen normally has 3 bonds, so we need to draw a little H there, okay? So that would be N-ethyl hexanamide. So here are some drawing structures from the names. These are all carboxylic acid derivatives. I hope this video has helped you. Please give a thumbs up